Good morning. This is section 1.3, continued and finished up. Elizabeth. No, I'm kidding. So I didn't get to the squeeze theorem, and it's also called the sandwich theorem. And it says, if h of x is less than or equal to f of x is less than or equal to g of x. So these are three separate functions. And if you look at this picture here on the left, you'll see three different curves. H is this curve on the bottom, so it would make sense that it's the least of all of those. And it's less than f of x. And f is this curve that's just above h but below g, so f is in the middle. And then it's less than g of x. G is the biggest of all of them, and it's above all of them. So it's important. They're not crossing each other. Like sometimes h is not below f, and sometimes h is above. So it's always like that. It's consistent through this whole piece of the graph on this interval. For all x in the open interval containing c, so c is just some particular value of x, except possibly at c itself. So we can't exactly tell what's going on right here at c. It looks like they're all intersecting at point c. But as long as h of x is less than or equal to f of x is less than g of x in the rest of the interval, then we can apply this theorem. And the theorem says the limit of h of x as x approaches c is equal to L, some value, L, is equal to the limit of g of x. So if that's true, if the limit of h is equal to L and so is the limit of g, then the limit of f, remember the f is the one that's in the middle. The f is like the ham in the middle of the two pieces of bread. So it's the sandwich theorem, or it's the squeeze theorem. So as long as the thing that's in the middle, if h and g are equal to each other, if the two pieces of bread have the same value, then by the sandwich theorem, the piece that's in the middle is also going to have that same value. So that's really all that says. We will see it a little more in the future. Okay, this is a short video today. We're just going to go on and discuss example 10 now. It wants us to find the limit as x approaches 0 of the sine of 4x over x. And we think, if only it was that special trig limit, sine of x over x. If only it was this. Then we would know what it would equal. But it's not. But it's super close. So watch what we're going to do. This is all fair and legal. We're going to take this and we're going to do 4 times this limit. Sorry, we're vacuuming outside. Let me backtrack. I want to show it this way. The limit as x approaches 0, I'm going to multiply 4 over 4 times that sine of 4x over x. So this 4 over 4 that we're multiplying by, that's just a 1. It's just a handy 1. So we're going to take the 4 in the numerator and move it in front of the limit, because treat it like a scalar. And we're going to take the 4 in the denominator and multiply it by the x in the denominator and get that. So that seems very illegal and tricky, but it is just fine. And now if we let y equal 4x, then I can rewrite this as the sine of y over y. Ah! And now we can use this limit. So this is 4 times all of this, which is 1. So the value is 4. Kind of cool.